Hello everyone, myself Nitra, studying in Sri Venkateswara College of Engineering, Bangalore. Today in this video, let us discuss about stack operations, infix to postfix conversion, and evaluation of postfix expression. First, introduction to stack operation. A stack is a linear data structure that follows the last in, first out principle. The main operation performed on stack are push, pop, and peek. Mainly performed or usually performed are push and pop. Stack operation are used in programming languages, data structure, and algorithms. First, push operation. Push operation adds an element to the top of the stack. It increases stack by 1 and updates the top pointer. If the stack is full, a stack overflow error occurs. Next, pop operation. The pop operation removes the top element from the stack. It decreases stack value by 1 and updates the top pointer. If the stack is empty, a stack underflow error occurs. Next, peak operation. The peak operation returns the value to the top element without removing it. It does not modify the stack size or the top pointer. It is useful for accessing the top element without altering the stack. Next, example of stack operation. Let us consider a stack with initial element A, B, and C. Pushing the element D will result in the stack having the elements A, B, C, and D. Popping an element will remove the topmost element D in this case from the stack. Next, implementation of stack operation. Stack operation can be implemented using arrays or linked list. Array implementation requires fixed size memory allocation, and linked list implementation allows for dynamic memory allocation. Array implementation. A fixed size array is used to store stack element. The top pointer keeps track of the index of the top element. Push and pop operations can be performed in constant time 0, 1. Linked list implementation. In linked list implementation, each stack element is a node in the linked list. The top pointer points to the first node. Push and pop operations can be performed in the constant time. Next application. Stack operations are used in function calls and recursion. They are used in undo and redo functionalities in text editors. They are used in backtracking algorithms and expression evaluations. Next, stack versus queue. While stack follows the LIFO last in first out principle, queues follows the first in first out principle. Stack operations are performed on one end while queue operations are performed on both the ends. Both data structures have use cases and are essential in programming. Stack application in programming languages. Stack are used for managing function calls and local variables in programming languages. They are used for expression evaluation and conversion in compilers. They are used for implementing backtracking algorithms like depth first search, DFS. Stack applications in data structures. Stacks are used in implementing other data structures like queue and hash tables. They are used in solving problems related to balanced parentheses and infix to postfix conversion. They are used in graph algorithms like topological sorting. Next, infix to postfix conversion. Infix notation in the typical value of representing mathematical expression such as 3 plus 4. Postfix notation, or also known as reverse Polish notation, place operator after their operands like 3, 4, 2. Next, example of infix to postfix conversion. Consider the infix expression 5 plus 2. The corresponding postfix expression is 5, 2 plus 3. Next, evaluation of postfix expression. To evaluate a postfix expression, we scan it from left to right. When we encounter an operand, we push it onto the stack. When we encounter an operator, we pop the required number of operand from the stack, perform the operation, and push the result back onto the stack. For example, consider a postfix expression 5, 2 plus 3, 4 minus. we start scanning from left to right. Continuing the previous example, when we encounter an operand 3, we push onto the stack. When we encounter the operator 4, we push onto the stack. When we encounter an operator minus, we pop 21 or we pop 2, 1, and 4, perform the subtraction, and push the result 17 onto the stack. Next, advantages of postfix notation. Postfix notation eliminates the need for parentheses to indicate the order of operations. It simplifies the evaluation process by eliminating the need for operator precedence rule. Postfix notation can be easily evaluated using a stack, making it efficient and straightforward. Next, limitations of infix notation. Infix notation can be ambitious when it comes to operator precedence. It requires parentheses to indicate the desired order of operation. Infix notation can be more difficult to parse and evaluate compared to postfix notation. Next, use of stack in infix to postfix conversion. Stack plays a crucial role in converting infix expression to postfix. It helps in maintaining the order of operator based on their precedence. The stack is used to temporarily store operators until they can be placed in the correct order in the postfix expression. Next, steps for infix to postfix conversion. Start scanning the infix expression from left to right. If an operand is encountered, add it directly to the output. If an operator is encountered, check the stack for operators with higher precedence. For example of infix to postfix conversion using stack. Consider an infix expression a plus b c minus d by e. The corresponding postfix expression is a, b, c. Use of stack in evaluation of postfix expression. Stack is essential for evaluating postfix expression. It requires the operand and perform the required operation. The stack allows for efficient and organized computation. Next, steps for evaluation of postfix expression. Start scanning the postfix expression from left to right. If an operand is encountered, push it onto the stack. If an operator is encountered, pop the required number of operand from the stack. Example, consider the postfix expression 5, 2 plus 3, 4 minus. We use the stack to evaluate the expression step by step. Importance of stack operation. Stack operation are fundamental in programming and algorithm design. They provide efficient ways to solve various problems and implement complex functionalities. Understanding stack operation is essential for computer science students and software engineers. Summary: stack operation involve push, pop, peek, and is empty. Infix to postfix conversion is done using a stack to maintain operator precedence. Evaluation of postfix expression is performed using a stack to store operand and perform operations efficiently. Conclusion: stack operations are essential of computer science and programming. They provide a simple and efficient way to manage data in lasting first out manner. By mastering stack operations, developers can solve a wide range of problems and build efficient algorithms.